Hi, class. We've finished all of our understanding about galaxies and the universe and space. One of the last things we ended with was how stars produced all of these elements when they died. And so we're looking at those. Yesterday, we took a look at how we can learn about something that we cannot see and we can't touch, but we can still learn about it. It was a little bit tricky, but certainly interesting. And today we're going to get into the brass tacks about atomic theory and atoms themselves. So you know the reason why atoms are really important. But before we get started, remember, you're going to be taking notes on this note sheet here. We're going to fill out these top two sections only today. So make sure that you're filling that out. If you need to pause or slow down or do whatever you need to do through the process of this to get all the notes, please do that. All right, important information here. All those atoms that we talk about, everything was created by stars, and they make up everything. So where do we move on from here? We want to talk about the parts and the particles within an atom. There are two parts, there are three particles, and they all have different properties. So let's start with the parts of an atom. The first part is the two locations. There is the nucleus. The nucleus contains 99% of the mass of the entire atom. And you got protons and neutrons in there, you can see in the diagram. And then the area around it is called the cloud. They're typically drawn as these rings, but just understand that those electrons can be anywhere in a sphere around the nucleus of the atom. And because 99% of the mass is in the nucleus, that tells you that electrons are really tiny. All right, so let's talk about those particles. First off, we have protons, and they have a positive charge. Their symbol is P, and they are located in the nucleus, as we discussed already. If you change the number of protons, protons are basically the element's identification. Like you have a driver's license or whatever, a student ID or whatever. It's how we can tell one element from another by the number of protons. So if the number of protons change, it's not the same element anymore. Next up, also in the nucleus, is the neutrons. Neutrons sound like the word neutral. They have so they have neutral or no charge. Their symbol is a small n, lowercase n. And they're located in the nucleus where 99% of the mass of the atom is. So if you change the number of neutrons, you're not going to change the charge. It won't get more positive or more negative, but you will change the mass. So the mass of the atom will change if we have more or less neutrons. And this is called an isotope when we have the same thing like carbon-12 or carbon-13 or carbon-14. That's basically just telling us that there is a different number of neutrons in those atoms of carbon, and the mass is different. Our last particle is an electron. This has a negative charge. Its symbol is a lowercase e with a minus after it. And they're located not in the nucleus, but in the cloud. And when you have a typical element or atom of an element, it's going to have the same number of protons and the same number of neutrons. That means its charge will be equal. If we take away an electron or we add an electron, then the charge either becomes positive or negative, and that's what we call an isotope. So if an atom loses or gains an electron, it will become an ion, okay? Excuse me if I said isotope earlier. It's an ion, and that means that that atom has a charge, either positive or negative. All right, you've heard of the periodic table before. You've probably looked at the periodic table before in one of your science classes in 6th, 7th, or 8th grade. We're not going to memorize it, but what we want to know about the periodic table is how do we get information from the periodic table. So here is one element off the periodic table, and we're going to break down all the information that is available to you in just this little square right here. So here we go. Starting off with the element name, which in this case is chlorine, followed by the chemical symbol of that element. Every chemical symbol has one capital letter in it, not two, not three, just one. So if you have a series of letters, you can tell how many elements are involved in that chemical formula based on how many capital letters there are. Every capital letter is a new element. Now, the atomic number, this is, again, as I mentioned previously, is the identification of any element. So it's the number of protons, and it is not different between one element and or it is different between one element and another. No two elements have the same number of protons. So if the number of protons change, you get a different number of elements. You get a different element, excuse me. And also, because the charge in a typical atom is equal, meaning the positive and the negative are the same number, that if you know the number of protons, which have a positive charge, then you also know the number of electrons, which have a negative charge. So for example, in chlorine, it has 17 protons, and it also has 17 electrons. The last thing we want to talk about is this number on the bottom, which is a decimal number. This is the atomic mass. And again, the mass makes up 99%. 99% of the mass of an atom is located in the nucleus. And so this is this number, this atomic mass number, is the number of protons and the number of neutrons put together. And then because I told you they have isotopes, which means some elements have different numbers of neutrons, then what they do is they average that out. That's how you get this decimal number. Cool.